Okay, so you have graphite, right? Graphite, I think most of you are familiar with it, right? It's one of the allotropes of carbon, and you all know that it's in your pencil and all these things, right? So it's like each layer, hopefully you all can see, each layer have strong covalent bond. Yeah, so this is O-level knowledge. Okay, then O-level tells you, right, between the layers you have weak interactions. I think in O-level, if I'm not wrong, we say that this is your van der Waals, van der Waals. Okay, I think O-level still teach this van der Waals, but A-level, right, we need to be specific. We don't use van der Waals anymore. We say that it is IDID. Okay, instantaneous dipole, induced dipole. Okay, so we need to be very specific. Okay, so basically they're saying that each carbon have one electron. Let me highlight one electron that can delocalize, making it a good conductor. This one you all already know since O level. Already know. Okay, so the structure is shown in 1B lah. Okay, so between the layers, there's only weak forces, which we call IDID. Okay. Different atoms can be fitted between the layers to produce unusual graphite compounds. Okay, so if you put group 1 metal like cesium, okay, you all know cesium is like period 5 or period 6, those kind of thing. It's a very big group 1 metal at the bottom. Okay, then they say a bronze colored solid. Okay, the color doesn't really matter for us. What's important is that they say that this solid, after you throw in the cesium, right, it has greater conductivity. Okay, so why does graphite conduct? You all know, right? Because it has each carbon, right, have one extra electron that can delocalize along the layers, right? So the electrons can fly around along the layers, okay, along the layers. Okay, now that we put cesium in, right, we stick in a cesium, they say this bronze color solid has greater conductivity. So guys, very common sense, right? If you have greater conductivity, means what has increased? The number of delocalized electron. So that delocalized electron came from who? Must be come from cesium, lor, right? Because that's the only thing you added in, Okay, anyway, they're going to ask you that question later. I don't want to jump the gun. Let's go on. Okay, there's another structure, right? Boron nitride. Boron nitride. Okay, it's very similar to graphite. It's also giant molecular layered structure. Giant molecular layered. Okay, so each nitrogen atom has a lone pair, but now this lone pair, right, is not delocalized. This lone pair, right, it actually forms a dative bond with a boron atom. Okay, so you can see, I'm just going to highlight for you like this dative bond. The arrow is very small, so yeah, bear with me. Yeah, all these are like your dative bond from N to B. Okay, it sort of looks like a benzene ring if some of you know what's a benzene ring. Okay, but even if you don't know benzene ring, don't need to worry. You don't need that knowledge. Okay, you don't need that knowledge. Okay, so figure 2B shows the bonding. Okay, well, good. Okay, so though boron nitride and graphite have similar bonding, this substance, boron nitrate, is a electrical insulator. Means what? Graphite is a conductor, but this boron nitrate is a insulator, means cannot conduct electricity. Okay, so means what? If something cannot conduct electricity, it probably means, yes, BT, absolutely bang on. No delocalized electron. Well done. So you already answered the question already. Later, before they ask, you already answered. Okay, so name the weak forces. Like what I said earlier, right? The weak forces we cannot say at A levels is van der Waals. We have to be very specific. We say that it is IDID. Okay, please spell it out. IDID. Instantaneous dipole, induced dipole. Okay, must be very specific, guys. Okay, so part B say graphite has a melting point 3007. Is it high or not? 3007. High, right? It should be very high. If you all say low, then something is wrong. It's very high melting point. Okay, so we want to account for it. So what kind of a structure does it have? Remember the very first question that we did tonight, right? We did the physical property. So the first thing we want to bring up for chem bonding is what type of structure are we dealing with? So 3700 graphite has giant molecular structure. Okay, so giant molecular structure. Giant covalent is also okay lah. There's two ways of writing it. You can say giant molecular, you can say giant covalent. Okay, what type of bond? Strong and extensive covalent bond between carbon atom. Okay, guys, if you are learning for your WA, please make sure to learn the phrasing well, yeah? Learn the phrasing. I'm not very anal about this phrasing, but the school teachers are. Okay, so your school teacher will be marking, and Cambridge also, they will be marking very strictly on your phrasing. So if your phrasing is like you anyhow write, GG, guys. Please make sure that you remember and practice how your school phrases it. Okay, it can be different from mine, that's fine. You just follow your school phrasing. So if it's a giant molecular, strong, extensive covalent bond, large amount of energy to break all these bonds. Okay. No, of course not, BT. I'm disappointed that you say that. Okay, if the weak forces is ID, right? Then you don't even need to boil it. It's like this ID is very easily broken. That's why when you put the graphite in the pencil, right, the layers slide off very easily. You don't even need heat. Yeah, because the bonding is so weak that you don't need any heat. Okay, so the fact that you have such a high melting point, yeah, correct. This is what makes graphite soft, slippery, soft and slippery. Okay, anyway, so that's the melting point. Only 2 marks, don't spend too much time on it. Okay, part C, name and describe the type of bonding found in cesium. Anyone knows cesium? Yay, well done. Cesium, metallic bonding. Okay, so the phrasing, guys, please take note, phrasing. Strong electrostatic force of attraction between C of delocalized electron and cesium cations. Okay, very straightforward, right? Okay, part D, explain how the introduction of cesium increases the conductivity. Actually, this part I already explained to you all just now. Okay, when you put in the cesium, you have to increase the number of electrons because they say the electrical conductivity actually went up. Okay, so the valence electron contributed to the delocalized electron. Okay, the valence electron in cesium contribute to the number of delocalized electron. So there's more charge carriers. So 1 mark. That's all we're gonna say for 1 mark. Okay, very very simple and straightforward. Okay, last question. Explain why boron nitride is an insulator, even though the structure and bonding is similar to graphite. Again, this part, right? I think I already shared with you guys the answer, right? Because there is no delocalized electron. All of it used for bonding. Three bond pairs and then 1 dative bond. Okay, all the electrons are being used up. All electrons are being used up. Okay, so that's it for the novel question.